everyone. My name is Kun. It's my honor to introduce our work here. We are a team from Tsinghua Shenzhen International School and Tsinghua University. The title of our paper is a dataset for exploring gaze behaviors in text summarization. To our knowledge, it is the first dataset which contains users' reading behaviors in the field of automatic text summarization. At first, I will give a brief introduction to our work. The dataset is collected by several high-accurate eye-tracking devices. The picture on the right is a schematic diagram of the process of collecting gaze behaviors. The dataset contains both users' reading behaviors and the summaries provided by them. Our collection platform works continuously when 50 users are reading 100 articles and composing the corresponding summaries for each article. After data processing, around 157 million gaze points are stored in the dataset. And based on our simple measurements on it, we found that users have their own stable reading patterns, and there are also differences in reading patterns among different people. This will be detailed later. The process of the data collection is divided into two parts. At first, we need to do some resource preparation. We use the 3 top eye tracking foci as the trackers in our experiment. It can sample 100 gaze points per second. 50 points graduates from various departments took part in the experiments. We manually collected 100 articles from public news websites. None of the selected articles can directly be summarized in the first sentence of the article. More details about the participants and the articles can be found in our dataset. We also designed our website to display the articles, and the eye tracker can record users' gaze behaviors when he or she is reading. And then the second part is the data collection procedure for every participant. Before starting to read the articles, every participant needs to complete the calibration of the device according to the instructions of the eye tracker and our website. After device calibration is completed, the participant enters the article reading stage. At this stage, participants are required to read the entire article as continuously as possible, with no limit on reading time. By adjusting the font size and the spacing between the Chinese characters, the gaze data returned by the eye tracker can be accurate to the level of the words. In addition, when displaying the content of the article, we put all the Chinese character of the same words on the same line. This avoids the jump in reading sight caused by a word appearing in 2 lines. After reading the article, the participant is asked to give a summary that she or he thinks fits the content of the current article. The participant can use words that don't appear in the original text to compose a final summary. At this stage, the original title of the article is presented as a reference summary at the bottom of the screen. The reason for providing a reference summary is to prevent the summary given by the participant from being too ad hoc. After the current user has read and summarized all the articles, we can get tracking logs of the entire reading process through the background program. First, we use the timestamps recorded by the web page program to obtain the log corresponding to each article. In actual experiments, it is found that the eye tracker still have a certain deviation from the test near the edge of the screen, which requires us to perform data calibration based on the original data. We just need to get the coordinates returned by the eye trackers on the four corners of the reading frame and calculate the offset. Our dataset has been uploaded to our website, and the statistics is displayed on the slide. The picture at the bottom right is the structure of our dataset. All the data is stored in CSV format or DAT format. The files with the DAT extension are binary files which can be loaded with the Python module Pico. The Pico module can transform a complex object into a byte stream. Here is a simple example. The outer layer is a dictionary, and the inner layer is a list of apples. And more details can be found in our paper. In order to compare the similarities and differences in the gaze distribution of different people during reading, we show the collected gaze behaviors in the form of a heat map. The brighter part of the heat map indicates that the participant has been reading the current area for a longer time. The three pictures on the right show the gaze distributions of three participants when they completed the text summary task of three articles respectively. The three articles shown in the figures belongs to different categories. Article 00 belongs to the mid-grade category. Article 77 belongs to the games category. And Article 92 belongs to the cultural category. It can be seen from the result that users have their own stable reading patterns. Specifically, user 8 tends to read through the whole article. User 10 tends to read the beginning or the end of the article. User 37 tends to read both the beginning and the end. And it is not difficult to find that different users have different emphasis on the same article. And then, in order to compare the summaries given by different participants from the semantic aspect, we fine-tuned a Chinese sentence similarity calculation model based on BERT. We first calculated the similarities between different summaries given by participant one or corresponding to the same articles. The picture on the right shows the summary similarity distribution in different categories. It is not difficult to see that there are large differences between the summaries, and many of the similarities are lower than the empirical value of 0.8. The distribution in different categories are also different, and the summaries in the cultural category have the lowest similarities. There may be a correlation between the differences among the summaries given by the users and the differences in their gaze behaviors. Thank you for your listening and any question.